Hello everyone. In this video, we will be solving problem 3005, count elements with maximum frequency. The problem statement is, we are given an array nums consisting of positive integers. We need to return the total frequency of elements in nums such that those elements have the maximum frequency. For instance, in example number 1, there are 6 entries in the nums array and the total unique numbers are 4. Amongst all of the numbers, the number 1 and 2 have the frequency of 2, which is the highest. As there are two numbers with the highest frequency 2, the output is 4. Similarly, in example number 1, we have all unique numbers starting with 1 all the way to 5. As there are no duplicates, the maximum frequency is 1. As all of the numbers share the same maximum frequency of 1, the total output is 5. As you must have guessed, the problem statement is very easy and straightforward, and so is its solution. Now let's switch to whiteboard and discuss how we can break this problem down into smaller sub-problems and solve it separately. We don't need to use any particular algorithm to solve this problem. Let's start by identifying the sub-problems that we need to break this problem down into and then solve it separately. The first step is to identify the frequency of all of the numbers in the given input array. After knowing the frequency of all of the numbers, we need to identify the maximum frequency amongst them. This step is dependent on the first step. The last step is to identify the entries or frequencies that match the maximum frequency. That is, look for all the entries in the collection that we built in step 1 that matches to the maximum frequency we're calculating in step 2. Let's do a quick dry run to understand how these sub-problems will help solve the problem. We'll begin with the first step to iterate through all of the numbers in the input array and record its frequency into this collection. Beginning with the first number, it doesn't exist in the collection, so its value will be 1. The next item is 2. As it doesn't exist, the frequency is 1 again. The next character is 2. It exists, so we'll increase its frequency from 1 to 2. Next entry is 3. It does not exist, so I'll add it with the frequency 1 and increment the pointer. The next element is 1. As it exists in the collection, I'll increment its corresponding frequency to 2. And the last element is 4, so I'll add it to the collection, setting the frequency to 1. Next step is to calculate the maximum frequency amongst all of these entries. This can be a very simple for loop to iterate through all of the entries in this collection and compare its output with the maximum frequency variable. And the higher value will be saved into the variable at the end. After completing the loop, the maximum frequency is 2. The next step is to identify how many entries are there in this collection that matches to the maximum frequency. So this could also be a simple loop to compare the value with the maximum frequency variable. Starting with the first entry, as the value matches to the maximum frequency, I'll add its corresponding value to the output. Now incrementing my pointer, the next entry value also matches to the maximum frequency, so I'll increment my output again, bringing it up to 4. As the remaining values in the collection do not match the maximum frequency, the output will not change. After iterating through all of the entries in the collection, we'll have the final result in this output variable. With this solution, our time complexity is O of n, where n is the number of elements in the input nums array. This is because we need to iterate through this entire collection at least once to record the frequency of all of the numbers before we can calculate the maximum frequency. Hence, the time complexity is O of n, while the space complexity is O of k, where k is the number of unique elements in the input collection. This is because we are using this collection to record the frequency of all of the unique elements in the input array. From the worst case point of view, the space complexity will be equal to O of n, where n is the number of elements in the input array. This is to cover the case where all of the elements in the input nums array are unique. I hope you are able to understand the explanation. Let me show you how we can implement this using CSharp. In this CSharp implementation, I've initialized a variable frequency which is of type dictionary to record the frequency of all unique characters in the input array. After that, I'm running a for loop to iterate through all of the characters in the nums array and record its frequency in this frequency collection. The next step is to identify the maximum frequency amongst the frequency that we have calculated so far. So for that, I'm running this for loop and comparing the maximum frequency variable with each of the entries. The highest value will be saved into the maximum frequency value after every checks. Next step is to identify how many frequencies are equal to the maximum frequency. So I'm running another for loop on the frequency collection and comparing if the count is equal to the maximum frequency. If yes, then I'm adding its value to the total. Once this for loop is complete, I am returning this total variable as the output. This code when submitted on LeetCode beats 96% of the submissions in terms of runtime and nearly 49% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.